Hey guys, welcome back everybody. Hope you all are doing great. Guys, today in this video we are going to understand one very important topic of switching, that is switch stacking. So we will see what is stacking, why we need stacking, how to configure it, like everything about stacking. You can say all about stacking. But before starting the session, I must tell you this video is very important for all network engineer. Why? Because guys, stacking is one technology which we are using nowadays in the real time in the production network. So if you are a network engineer or if you are planning to become a network engineer, make sure you will watch this video till the end. Because guys, in the production network, you are going to configure it, you are going to troubleshoot it. Okay. Now without wasting our time, let's begin. First of all, we are going to understand why we need stacking. Then we will see what is stacking. After that, we'll see the configuration, how to configure it. And guys, to understand why we need stacking, just suppose we need to connect some end devices together. Let's suppose you have 100 end devices, right? Like PCs, servers, printer, IP phone, IoT devices, and you need to connect these two devices together. How you will connect? You have two options. Either you can connect them together with the help of AP to form a wireless network. But guys, wireless network depends on various factors, right? So other option is we can use a centralized device, that is switch. So with the help of switch, we can connect multiple devices together, multiple end devices together, right? So let me give you one example to make you understand why we need stacking. Okay, after that it will be very easy for me to make you understand what is stacking. So let's suppose guys, I have some end devices like PC, server, IP phone, printer, IoT devices, right? And you need to connect these devices together. What you will use? You will use one centralized device called switch. So let's suppose this is your switch 1. But guys, you need to connect 100 number of devices together, and on the switch you have only 24 ports, or let's say 48 ports. So you need to purchase multiple switches here, right? You need to purchase multiple switches, right? Maybe 3 switch, 4 switch, 5 switch. But in the real time, in the production network, in the enterprises network, or in the data center guys, you will have 1000 number of switches, 100 number of switches, 500 number of switches. Okay, so in that scenario, how you are going to connect switches together? So let's suppose this, on this switch I have 24 ports, and guys, out of 24 ports I have used, let's say, 20 ports to connect end devices. This is switch 1. Now I have few more end devices, so I need more switch, right? So let's say I am using one more switch here to connect more end devices together. This is my switch 2, right? This is my switch 3. So I have 3 switch to connect end devices together. Now here, let's suppose I have some end devices, right? And with the help of Ethernet cable, I can connect all end devices together. Now the next task is, first you have connected all end devices together with the help of switch. Now you need to connect these all switches together, right? So that these devices can communicate with each other at layer 2. At layer 2. So let's suppose these all ports are fast Ethernet port. This is F0/1. So guys, fast Ethernet port has bandwidth of 100 Mbps, correct? So I can use, let's say, one port to connect switch 1 and switch 2 together. Now the bandwidth between switch 1 and switch 2 is 100 Mbps. And guys, this link is shared link, right? This link is shared link. Let's suppose we have 100 users on switch 1 and switch 2. Then all 100 users are going to share this link, right? And as bandwidth of this link is 100 Mbps, right? And I have 100 number of users on switch 1 and switch 2. That means one user will get around 1 Mbps bandwidth between switch 1 and switch 2. So you need to increase bandwidth between switches. Let's suppose I have some critical server on switch number 1, right? So I need more bandwidth between switches, or you can assume that switch 2 is connected with one router and that router is connected with internet. Now outside users are accessing this server. Let's say this is server, this is one server, and outside users are accessing this server every day, or my remote branch users are accessing this server. Means I have 1 lakh client, 1 lakhs client, or 10,000 clients. So all 10,000 clients are accessing this server multiple time. So guys, all lakhs users or 1,000 users are sharing this link between switch 1 and switch 2. So definitely you will have issue with bandwidth between switch 1 and switch 2. Right? Now how you will increase the bandwidth between switch 1 and switch 2? You can connect multiple link. You can add one more fast Ethernet link. If you will add one more fast Ethernet link, now you have 200 Mbps, but you know STP will block one link. STP is going to block one link. Even you can connect 4 link between switch 1 and switch 2, but STP will allow only one link to forward data. But again you have another option. You can combine all link together with the help of Ether channel to utilize all links between switch 1 and switch 2. Then a spanning tree protocol will work on the virtual port channel, right? So switches are going to use all links, right? It will perform load balancing. But also guys, see how many bandwidth I have between switch 1 and switch 2. I have 4 fast Ethernet link. That means I have 400 Mbps bandwidth. Again, this bandwidth is very less for the real-time scenario, right? For the data center or for the big enterprises company where we have guys 500 number of switches or 100 number of switches. In that scenario, 400 Mbps bandwidth between switches is very less, right? So even if you are thinking that no Propul, I will connect gigalink. So then also brother, if your ports are giga ethernet port, then you have 4 gig bandwidth between switch 1 and switch 2. Again, this is very less. As I told you, let's suppose outside users are accessing one server on switch 1, right? And you have lakhs of client. So the bandwidth between switch 1 and switch 2 is shared. All your clients are going to use this bandwidth. So here you need guys more bandwidth, right? But assume that 400 is, let's say, sufficient, right? I can connect 4 link between switch 2 and switch 3 also, like this: 1, 2, 3, 4. Because try to understand the another issue, right? This is the first issue, because even I am connecting multiple links between switches, then also I have less bandwidth. And if you are thinking that okay, I will connect 20 number of cable between switch 1 and switch 2, you will connect 20 number of cable, right? And guys, see the cost. If you are connecting lots of cable between switches, right, that means cost is also increasing. And the main issue is, now see, on the switch total number of ports are 24. And out of 24 ports, you are using guys 4 port to connect switch. So how many left ports are available to connect end devices? 20. So I can connect only 20 users on switch number 1. On switch number 2, I have total 24 ports, and out of the 24 ports, I have used 8 ports to connect switches. So I have only 16 number of available ports. So I can connect only 16 users on switch number 2. And guys, this topology is small, right? I have only 3 switch. So that's why here we have still 16 ports available. But if you have lots of access layer switches, then you will have a very less number of ports to connect end devices. So that's why nowadays we are not using this technique to connect multiple switches together, right? Because the main purpose of switch is what? To connect end devices together, like my PCs, servers, IoT devices, printers, IP phone. These devices are connected through switch, and this is the main function of switch. But here I am using lots of port to connect switches together, right? And like this, if you have 50 number of switches, guys, let's suppose switch 2 is connected with one another switch as well, right? Here also you are using 4 link, so now you have only 12 number of available ports on switch number 2 to connect n devices. So just assume if I have 50 number of access layer switches, then it is going to be very impractical, right, to connect switches together with the help of Ethernet port. Ethernet port are used to connect n devices. Earlier we were connecting devices like this, access layer switches like this, but nowadays we are not connecting n devices like this, right? Because assume now if you need to connect 50 access layer switches together, so you are going to connect it through Ethernet port. So how many cable you are going to use first of all, right? 4 cable between 2 switch, and you have how many switch, guys? 50 switch. So you're going to use around 200 cables, right? 200 cables. If you have 1000 number of switches, maybe you are going to use 500 cables, right? So like this cost is also going to be increased. So that's why nowadays we are not connecting multiple switches like this, right? If I am using these switches to connect n devices together, like in my scenario, these all 3 switches are responsible to connect n devices, are responsible to form a LAN, local area network. Then guys, connecting switches together with the help of Ethernet port is not impractical, is not practical. So what other option I have? The other option is, guys, stacking. Other option is stacking. First of all, hope it is clear like why we come up with stacking. We come up with stacking to overcome this issue, right? Like to increase the bandwidth between access layer switches and to avoid using Ethernet port to connect multiple switches together, right? Because still we have 400 Mbps link here, 400 Mbps link here, and I am using 8 ports on switch 2 to connect other switches, right? So I have only 16 ports to connect n devices. Done. So what other option we have, guys? Other option is technology. Which technology? Stacking technology. With the help of stacking, what you can do, you can combine these switches together without using Ethernet port. Without using Ethernet port. So first of all, let me tell you what is stacking. Then we'll see how stacking works. So guys, if someone will ask you what is stacking, it is very important for interview as well, because interviewer, most of the time interviewer is asking question from this topic, because we are using this technology in real time. Okay, so guys, you can say it is an technology which is used to combine multiple switches into a single switch. See, if you are connecting these switches together with the help of Ethernet port, that means, guys, control plane is distributed, right? Switch 1 have their own control plane, switch 2 have their own control plane, switch 3 has their own control plane, right? Like switch 1 is generating their own VTP message, DTP message, STP message, switch 2 is generating their own, switch 3 is generating their own. But in the stacking, when you will combine these all switches together, so actually you are going to centralize the control plane traffic. You are going to centralize the control plane traffic. Out of these 3 switch, one switch will become master switch, and one switch is going to manage all control plane traffic, right, between switch 1, switch 2, switch 3. Okay, so with the help of stacking, what we can do, we can combine multiple switches together. Now how? So see, guys, first of all, this stacking option is not available on all switches, right? If I will talk about Cisco switches, right, Cisco access layer switches, see why I am saying that which switch you should purchase depends on the requirement. Because see, guys, Like if I need to connect multiple end devices together, so I need a switch. So I can purchase switch from the market, but it is not like you can purchase any switch, right? According to your requirement you have to choose device, because there are lots of switches in the market, right? And in the a small network, in the a small office, let's say, where you need to connect 50 number of computers, so you need only two switch. So there you can connect both switches with the help of ethernet port, or directly you can connect switch to your router, right? There you are not going to use stacking. So you don't need to purchase switch where a stack port should be available, because if a stack port is available, then that switch will be costly. These are access layer switches. Again, in access layer we have two types of switch: manageable and unmanageable, right? So some switches has a stack port, some switches don't have a stack port. If I will talk about Cisco switches, guys, so all 3750 series switches, or you can say 3750 plus series switches, have two stack port on switch, two stack ports, right? So if you need to combine multiple switches, then you are going to purchase 3750 series switch, or 375 plus series switches, right? Not below 375 series switches. If you have switch below this series, then I think a stack port will be not available there, right? So stack ports are available on 3750 switches or any later series switches, right, of 3750. Done. Now how a stack port look likes? See guys, on the Google you can say a stack port on the switch, and see lots of images are there. Like Ethernet port, you can see these are Ethernet port. In the same way, on some switches you will have a stack port, like you can see on this switch. On this switch I have one stack port. These are what? Stack port. So on each switch you can see we have two stack port. And guys, how many switches are there? 1 2 3 4 5 6 7 8. How many switch I can combine in stacking? Up to 9. You can connect up to 9 switches in a stack. Now question is, how we will connect switches in a stack? So guys, you are going to use one different cable. Like here, to connect n devices to switch, you are using what? Fast Ethernet cable, right? And in fast Ethernet we have multiple types of cable, like a straight through, crossover. Like that we have one Stackwise cable, a stack. Okay, so first of all you need to purchase the switch which support stacking. Support stacking means you will have a stack port on that switch, right? If a stack port is not available, then definitely you can not use this technology. Then you have to connect two switch with the help of Ethernet port only, right? But if a stack port is available, then you need to now purchase one stack cable, multiple stack cable. That's again depends on your requirement. You are combining how many switches in a stack, right? So if you are connecting two switch in a stack, you can connect them with the help of single stack cable also, and you can use two stack cable also for redundancy, right? So a stack cable looks like this. You can say this is my stack cable, right? So I'm going to put one end of a stack cable on switch number 1 and one end of a stack cable on switch number 2 on the stack port. Then these two switches are going to share their control plane traffic as well as data plane traffic with the help of stack cable. And if I will talk about the bandwidth of a stack cable, so guys, bandwidth of a stack cable is 32 gbps. 32 gbps. Don't worry, we will see how a stacking works, right? So bandwidth is, see now, very high, correct? So if you are connecting two switch with the help of a stack cable, that means you have 32 gbps bandwidth. And this is also a stack cable. You can see port. So we have again different types of stack port on the switch, right? So even you can use the connector to connect switches in the stack, or you can use different cable, right, according to your requirement. And this is how we are going to connect switches together in a stack. Let me tell you how you are going to connect two switch in a stack. Let's suppose I have two switch 1 and switch 2. Guys, this both switch supports stacking, let's suppose. So this switch have one stack port here and one stack port here. Two stack ports are there, right? On this switch also I have two stack port. So what I can do, I can even use one cable, right? Now see, switch 1 and switch 2, both switches are connected together, switch 1 switch 2, with the help of stack cable. Bandwidth is 32 Gbps, right? But guys, if this stack cable bill goes down, then connectivity will goes down between switch 1 and switch 2. So that's why I have two port. So you should use one more cable here to connect these two ports as well together. This is how we connect switches in a stack. So actually you need to form ring topology, right? Means stack port 1 of switch 1 will get connected with stack port 2 of switch 2, right? And port 2 of switch 1 will get connected with switch 1 of port 1 of switch 2, like this. Now here suppose I have some user and user. These users are in, let's say, VLAN 10, and I have here also some two users, both are in VLAN 10. So how these users are going to communicate with each other? With the help of stack cable. With the help of stack cable. And guys, now we have a single switch, right? Now these two switches are combined, right? We have combined these two switches. So now one switch will become master switch. So let's suppose switch 1 is my master switch. So switch 1 is going to manage control plane, right? It will generate STP BPDU, then it will forward STP BPDU to switch number 2. From which port? From the stack port. So if you are thinking that a stack port is also participate in STP, no. A stack port is not participated in STP, but switches will use that port to forward STP data. That's it, right? STP is running on Ethernet ports only, but it will share BPDU, it will share DTP message, VTP message through a stack port. Now if I have some user here, two user in VLAN 10, here I have two user in VLAN 10. How these two users are going to communicate with each other? With the help of, guys, stack port, right? Actually, now you cannot access switch number 2, right? Because as I told you, now we have combined these two switches together. So let's suppose switch 1 is my master switch. So control plane is not centralized, right? Only switch 1 is managing control plane. So you will access which switch? Switch 1. So let's say this is management PC, admin PC, right? To configure both switch 1 and switch 2, you have access switch number 1. Let's say this is 0/1 port, this is 0/2 port, this is 0/1 port, this is 0/2 port. Now these two switches are combined. So guys, their ports will be, first this port will get port ID 1/0/1, means first number is the stack number. So all switches in the stack will get one stack number. Let's say stack number of switch 1 is 1, stack number of switch 2 is 2, right? So 0/1 port ID will be converted into what port ID? 1/0/1, right? Now this 1 is identifying the switch in a stack, right? So this port will have what port ID? 1/0/2. This port will have what port ID? 2/0/2. 2 means switch number 2 in the stack, right? 1, 2/0/2. And now I need to configure these ports in VLAN 10. So simply on the management PC, you will access switch number 1, and on the access numbers on the switch 1 you are going to configure this port 2/0/1, 2/0/2, 1/0/1, and 1/0/2. These all ports in VLAN 10. So on these all port you are going to run command switch port access VLAN 10. Let's say if you want to change the port number here of switch number 2, you have to change number, stack number on switch number 2. Done. So let's suppose I have 4 switches and I need to connect them in a stack like this. You can see how I have connected 4 switches in a stack, guys. Switch 1 is connected with port, stack port 1 of switch 1 is connected with stack port 2 of switch 2. Then port 1 of stack port 1 of switch 2 is connected with port 2 of stack port 2 of switch 3. Then stack port 1 of switch 3 is connected with stack port 2 of switch 4. After that, stack port 2 of switch 1 is connected with stack port 1 of switch 4. So now you can see these switches are in ring, right? Even if one stack cable will goes down, let's suppose if this cable is down, right, not working, then also these switches are connected through a stack cable, through a stackwise cable, right? So these switches can communicate with each other. So as I told you, on this switch, let's say I have one user here in VLAN 10 and port ID is 1/0/1, and I have here one user in the same VLAN, let's say in 10, port ID is 4/0/1. So port number 4/0/1 means I'm talking about switch number 4 in the stack, then slot number 0, then port number 1 or 2, right? So if this switch is the master, one switch will become master switch. Now if you are thinking which switch will become master switch, don't worry, we will see the election. So if switch 1 is the master switch, you will access switch 1 and you can configure any port. So now on this switch, on switch number 1, on the master switch, you will have port from 1/0/1 to 4/0/24. Let's suppose there are 24 ports on each switch, right? Let me do one thing. Let me design one topology here to make it more easy, because stacking is, guys, important. So you have to learn it very carefully. Now let's suppose I have two switch 1 and switch 2. I want to combine these two switches in a stack. This is my switch 1, this is my switch 2, and between switch 1 and switch 2, let's suppose I am using only one stack cable, right? This is a stack cable, a stackwise cable, stackwise cable, right? And here I have one user, and here also I have some users. Now I am going to connect these PCs together. Let's suppose these switches have 24 ports. These are 24 ports, 24 Ethernet port switches. So now I can connect first of all 24 end devices, because all Ethernet ports are free on switches, right? And guys, port ID of this port is, let's say, 0/1, then 0/2, then 0/3. This port 0/1, port ID of switch 2, 0/2, and 0/3, right? Now these switches will behave like a single switch. As I told you, combining multiple switches together is stacking, right? It will work like this. Now this is the new switch, guys. After the stacking, this is a single switch. And let's suppose this is PC1, PC1, PC2, PC3, PC4, 5 and 6, right? Now you know in the new switch, on the new single switch, you have 6 computer connected with single switch. After the stacking, you have 6 number of users here: 1 2 3 4 5 6. Port ID of this interface is 1/0/1. What I am assuming that stack number of this switch is 1 and stack number of this switch is 2, right? So see, PC1 is connected with switch 1, so stack number 1, then interface ID. And guys, PC2 is connected with which port now? 1/0/2. PC3 is connected with which port now? 1/0/3. PC4 is connected with which port now? 1/0/ not 1/ 2/ stack number 0/1. This port PC5 2/0/2. And guys, PC6 2/0/3, right? Now as I told you, you will access the main switch. So say, let's suppose this is the admin PC for the management. Now I have accessed this switch, new single switch, combined switch with the help of, let's say, console cable. This is my console cable, or even you can access it through telnet. Done. PC. So let's suppose I need to configure PC1, PC4 in VLAN 10 and PC1 and PC4 in VLAN 10, and I need to configure PC2 and PC5. Wait. PC2 and PC5 in VLAN 20. So how you are going to configure it? On the admin PC, you will first access the switch. Which switch? Master switch. Then you are going to run command interface range F 1/0/1 switch 1. Then PC4, port ID of PC4. See guys, this is your PC1, PC2, PC3, PC4, PC5 and PC6. So PC1 and PC4 is in VLAN 10. So you are going to run command interface range F 1/0/1 means PC1, then PC4. PC4 is connected with which port? F 2/0/1, right? Then here I am going to say switch port access VLAN 10. Done. After that, I need to configure PC2 and PC5 in VLAN 20. So interface range F 1/0/2 F comma F 2/0/2 switch port access VLAN 20. Done. So now this user is in VLAN 10, this user is VLAN 10, this user in VLAN 20, and this user is in VLAN 20. Now how these two users are going to communicate with each other? See, let's suppose IP address of this machine is 10.1.1.1. IP address of PC4 is 10.1.1.2. Right, for VLAN 10 my subnet is 10.1.1.0. right, this PC2 IP address is 20.1.1.1 and PC5 IP address is 20.1.1.2. so when PC1 will ping to PC4 source IP 10.1, destination IP 10.2, source MAC PC1 MAC address, destination MAC PC4 MAC address, right, then it will forward to switch. It will forward to switch. Now the user is connected with switch number 1. User is connected with switch number 1. So switch user will forward traffic to switch number 1. And switch number 1 is a stack. Right? So switch 1 is going to learn MAC address of this PC source MAC. After that it will check destination. If destination is not available in the MAC address table, then it will forward it from the stack port. It will forward from the stack port to switch number 2. Even it will forward to other port on same switch if any other ports are available in same VLAN, right? So on the Stackwise cable, on the Stackwise port, you don't need to configure trunk or anything like that. All VLANs are allowed. What I told you that these two switches are behave like a single switch. Just assume that both PCs, this PC and this PC, PC1 and PC4 are connected with same switch. So if both are connected with same switch guide, then how switch is going to forward traffic? Switch will receive traffic on this interface, it will learn MAC, it will check destination. If destination is available, it will forward from that port. If destination is not forward, then it will broadcast it in the, that is unknown unicast forwarding from all their interface except receiving interface, right, in the same VLAN. So in the same VLAN, in the VLAN 10, we have one more port, this port. So it will out from this port. It will forward the packet from this port, right? This is how switches is going to forward traffic in a stack. So both switches behave like a now single switch. And like this, we can connect, we can combine up to 9 switches. Done? Hope it is clear. Now question is, which switch will become active switch, master switch? So guys, let me discuss election criteria of master switch. We can combine up to 9 switches together, and let me do one thing. Let me design one again topology. Switch 1, switch 2, switch 3, and switch 4. I'm going to connect these switches in a stack. So what I need, a stackwise cable. Here a stack port 1, a stack port 2, stack port 1, stack port 2, switch 1, switch 2, switch 3, and switch 4. Now how I can connect it? Port number 1 of switch 1 will be connected with port 2 of switch 2, like this, and then this. Now you can see topology is in ring, all devices are in stack, right? So guys, on switch number 1 we have 24 ports. So now ports on switch number 1 is 1/0/12, 1/0/24. On switch number 2, 2/0/12, 2/0/24. On switch number 3 also 3/0/12, 3/0/24. And on switch number 4, 4/0/12, 4/0/24. So on the single switch, now we have these all ports. On the single switch we have these all ports. Now which switch is going to become master switch? So election criteria of master switch. Of master switch. First thing, highest priority. Highest priority, right? Switch who will have highest priority, that switch will become what? Master switch. And priority is, guys, range of priority is range of priority is 1 to 15, and by default value is by default 1. By default is 1, right? So by default priority on all switches is same. Here on switch number 1 also priority is 1, on switch number 2, 3, 4, on all switches priority is by default 1. Then which switch will become active? So if priority is tie, see why priority is useful. By default it is same on all switches, but let's say if I want to configure switch 1 as a master switch. Master switch means you are going to perform all configuration on master switch. Let's suppose you want to configure one port in VLAN 100. Port number is 4/0/1. 4/0/1. Here it is 4, not 3. 4/0/1. Let me correct it. 4/0/1. So if you want to configure 4/0/1, so you are that means you are not going to access switch 4, right? You will access switch 1, any master switch. You will access any master switch. Master switch can be switch 1, switch 2, switch 3, switch 4. First of all, it will check priority. If priority is tie, or first of all, switch which will come up first, that switch will become master switch. But let's suppose if all switch will come up at the same time, then it is going to check priority. If priority is same, then it is going to check system MAC address. Second is system MAC address, means base MAC address of switch. And guys, switch with lowest MAC address will become master. So let's suppose switch 1 MAC address is 0A, switch B MAC address is 0B, switch 3 MAC address is 0C, and switch 4 MAC address is 0D. So by default priority is same on the all switches, and switch 1 have lower MAC address, base MAC address. So switch 1 is going to become what? Master switch. Now if you want to configure 4/0/1, right? You want to configure this interface 4/0/1 in VLAN 100. So you will access which switch? Master switch. Which is the master switch? Switch number 1. So I am going to connect admin PC to switch number 1, right? And on switch number 1, now if I will run command show IP interface brief, it will show me all these interfaces, right? 24 24 24 multiply by 4, right? Total number of ports on the master switch is now 48 multiply by 4, right? So you can configure any switch. Done. And how master switch is going to send STP BPDU? From the Stackwise cable. How master switch is going to forward data? From the Stackwise cable. So now in this scenario, I have one user in VLAN 10 at each device. So guys, these devices are going to communicate with each other with the help of stack cable. Now what you can say, all control plane traffic will be travel through Stackwise cable. All data plane traffic will be travel through Stackwise cable, right? Now between switches we don't have any Ethernet cable. Okay. And don't think like if it is sending BPDU from the stack port, that means this port is participated in STP. No, right? Because these switches are single switch now. Okay. So all VTP message, DTP message, STP message, ether channel message, all messages will be transmitted through a stack port only. So what we can say, now I have a single switch where guys I have lots of ports. So I can connect 4 multiply by 48 devices, right? And first port is 1/0/1, last port is 4/0/24, right? So these all ports are available on single switch. Now in the same way, let's say at second floor also you have guys same scenario. There also you have combined 4 switches together, right? In the same way, now you want to connect these two logical switch together. So what you can do, you can use now Ethernet cable again, right? Here also I have 4 multiply by 48 ports, right? Let's say 1/0/1 to 4/0/24, right? So I can use any port on switch number 1 and switch number 2. Let's say I want to connect these two switches together, can connect like this, right? Maybe this port can be 1/1/1, and this port can be 4/0/ let's say 10, right? So both logical switches are connected together with the help of what? Ethernet port, right? So this is how we can increase number of Ethernet port on a single switch by combining multiple physical switches into a single logical switch. Now see the configuration. So guys, here I have access of one switch, right? Now here if you will run command, so interface status, so see the port 1/0/1, that means this switch is in a stack, and their stack number is 1. Stack number of this switch is 1. If you will change the stack number, let's say you want to change the port number here, you can change the stack number. If you will configure stack number 2 on this switch, then ports will become 2/0/1. If you are a network engineer, you might have observed these things in real time, right? Sometime port is 3/0/1, 4/0/ or 9/0/1, right? So you can combine up to 9 switches in a stack. But guys, I don't have a stack cable, so I cannot connect two switches together, right? But I can show you the practical. See here, this switch is in a stack, that's why we have a stack number, right? How to verify the stack configuration? Simply you can run command show switch. So you can see this switch is the master switch. And guys, stack number is 1, priority is 1, base MAC address is this one, and current status is ready, right? So this switch is in a stack. Why we don't have port number of another switch, guys? Because this switch is not connected through a stack cable to another switch, but this switch is in stack, right? If you want to change the stack number, what you can do? First of all, what you need to configure in real time? Priority, right? Let's say I want to make switch 1 as the master switch every time. So what I can do, I can change the priority over here. Simply I can say switch, and then guys, switch number, stack number, see switch number. So let's say switch number 1, and then priority. Let's say what? By default priority is 1. I can configure priority from 1 to 15. So let's say priority is 10, right? Confirm. New priority has been set successfully, right? Now if you will run command show switch, so you can see priority is what? 10. So now this switch will be my master switch always. If you want to change the number, in a stack, first of all, what we can do, we can, okay, let me configure the number. How to change the stack number on switch? So say switch, and then current stack number is 1, right? How to verify current stack numbers? By running command show switch. Stack number is 1, current stack number, right? Now I'm going to say switch and then current stack number, and after that renumber. Okay, so say renumber, let's say 2, confirm. What it's saying, new switch number will be effective after next reboot. So what I can do, I can reload the device. When I will reload the device, it will set the number to a stack number. So let me say reload here, right? So wait for some time. After the reload, you will see a stack number on this switch is 2, and if a stack number is 2, then their ports will be start from 2/0/1, 2/0/1. Done. It will take some time. Till then, you can see some diagram of stacking here. Stackwise switches. So see, in the rack, you are going to put 4 switches, 5 switches, up to 9 switches, and you can combine them together with the help of stacking. After that, you can connect lots of end devices together, right? So see, these devices are in stack. These devices are in stack, and see how a stack port look likes. This is your stack port. Let me copy the image and let me paste this image over here. See, stack 1, stack 2. This is a stack port 1. This is a stack port 2, right? So let's suppose I have 2 switch. On both switch, guys, I have 2 stack port. Now you know how to connect them, right? How to combine these 2 switches, right? You need a stackwise cable, so you can purchase it from the market, and then you can connect it like this, right? So let's say on this port, on this switch, we have 48 ports or 24 ports. Here also we have 24 ports on switch number 2. So on new switch, guys, on the new switch, how many ports I have total? "48 ports", right? Let me check the device has reloaded or not. Yes. Now you can see here what we can do. So interface status. Now you can see ports 2/0/15, 2/1/1, and so switch. So you can see this is the previous entry. After some time it will remove it. Now you can see the new stack number of this switch is 2, right? So this is how you can configure a stack number on switch. How to configure the priority. You cannot change the MAC address because MAC address is the permanent address, right? So that's why we have priority concept to make a specific switch as a master, right? And then, guys, role, then the MAC address, and all rest switches are slab switch, right? So if I will connect this switch to any other switch with the help of a stack cable, so you will see switch number 2 or other switch will become what? Slab, right? Like here, switch 1 switch will become master and this switch will become slab. Let's say I have 4 slab switches, so slab 1, slab 2, slab 3, slab 4, like that you can say. Okay, then there are some more command here. Let me check. Switch and put the question mark, so it is asking for switch number. So now my switch number is not 1, now my switch number is 2. Then you can configure the priority, you can change the number. So we have only these options here, right? For the verification, so switch, this is the first verification command. Then guys, so switch, and we can define the switch number, that is 2. It will also give same output, but here I can say, I think, detail. So see, the stack port is now down, because as I told you, devices are not connected with a stack cable, right? These switches support stacking, so that's why ports are down, right? There is no neighbor, right? If you will connect this switch to another switch with a stack cable, you will see the neighbor, right? Here it will show you the port, right? So actually this is what stack port 1, stack port 2. Getting my point? So like, what I can do to make you this concept clear, I can again connect two switch together. Stack port 1, stack port 2, stack port 1, stack port 2. Like this. 1, 2, 1, 2. Switch 1 and switch 2. So on switch number 1, when you will run command, this command, so switch details, it will show you first of all a status up, right? On which port. Let's say I have connected only one cable, means port 1, stack port 1 is connected with stack port 2, or even I can connect a stack port 1 to 1 also, right? No problem at all. Even we can connect a stack port 1 to a stack port 1, stack port 1 on switch number 2 also, right? So this is port number on the local switch, on the master switch. Let's say this is my master switch, right? This is port number 2 on the master switch, and this is port number 1 of neighbor, port number 2 of neighbor, port number 2 of neighbor, right? So actually guys, what you can say, this port is talking about this port, this port is talking about this port, this port is talking about this port, and this port is talking about this port, like that. Now is there any other command? Let me check. So switch details, before the details we can run neighbor command. So you can see we don't have any neighbor on port number 1 as well as on port number 2, right? And I can use stack port command here, stack ports. So my both stack ports are down. Then I can check stack ring and activity, right? So when you will connect these devices in a stack, then you can see the bandwidth also, right? Here I have one option to run a speed command. Why I'm not getting a speed command here? Stack ring and speed, stack port, and speed is not there, right? A speed option. But I remember in the real time I was working in a company where I had checked the speed on the stack port, and it was 32 Gbps. So don't know why here I am not able to run this command. Command was so switch stack ring and speed, right? Maybe this command is not applicable on this series of switch. So version, if you want to see the version of this switch, so you can see guys, this switch is 3750. As I told you, on 3750 switches only you will get a stack port, right? Or on 3750 plus series switches. Done. So this is all about stacking, right? Switch stacking. Guys, if you have learned something from this video, please hit on like button. If you have any question, concern, please let me know in the comment section. If you want any video on any other topic, please let me know. And if these type of videos are helpful for you, you want more videos like this, then just type yes in the comment section. Guys, your yes is very important for me. Your yes is going to motivate me to make more videos, right? So if this video is helpful for you, and if you want more videos like this, then please type yes in the comment section. Once you will type yes in the comment section, I will get to know that you guys like this type of video and you want more videos like this. So it will motivate me to make more videos, right? I will try to upload more videos like this on my channel. That's all for today. Thanks for watching. We'll meet on next video, guys. Till then, stay safe. Bye bye. That's all for today.